For the second section, you will dive deeper. You will be using two different data sets with different resolutions, and we will work with interpolation. The two data sets that we considered are CPC globe and GradeMed minimum temperature data. CPC globe has around 50 kilometer spatial resolution, whereas the same for GradeMed is around 4 kilometers. Here is a summary of the main functionalities that we will be practicing in this session. Interpolation, conversion to 360 longitude axis to 0 to 360 longitude axis to minus 180 to 180. Scaling a data set, for example, converting degrees Kelvin to degrees Celsius. Rolling average. In this section, we import libraries again to keep the examples separate from each other in case someone wants to start from here. Now let's download the two datasets for 2021. Firstly, downloading GradeMed T-min, then downloading CPC Globe T-min. Okay, now let's open the two datasets and explore them. Display DS GradeMed. Now display the CPC dataset. Now let's plot the original data for January 1st. Subplot for GradeMed data, then subplot for CPC globe data. Finally, adjust the layout for better presentation. That's the created figures. Looking at the two datasets, we see that there are a few differences that should be addressed. In the GradeMed dataset, the CRS coordinate can be dropped and the day coordinate can be renamed to time to be consistent with the CPC dataset. The GradeMed data is in Kelvin, but CPC is in Celsius. Let's convert GradeMed data to Celsius. In addition, the lone coordinate in one dataset is from 0 to 360 and minus 180 to 180 in the other one. Let's change that to 0 to 360 for the GradeMed data. Lastly, let's interpolate the Corsa resolution data to the GradeMed resolution. Now display the revised GradeMed dataset. Interpolating the CPC dataset to match the latitudes and longitudes for the revised GradeMed dataset. Now let's take a look at February 16, 2021 for the regions in Texas where the severe cold storm happened. Firstly, we convert time coordinate to datetime format for DS GrideMate revised. Then we convert time coordinates to datetime format for DC CPC interp. Then we will creating a target date object using the datetime module. After that, converting the target date object to a pandas datetime object. After that, we plotting the result by create a figure with a specific size and white background. Then plot the first subplot. Select and plot the tmean variable from dsGrideMate revised for the target date. Then set the title for the subplot with the target date. After that, plot the second subplot. Select the plot the tmean variable from the SCPC interp for the target date. After that, set the title of the subplot with the target date. Finally, adjust the layout of the subplots for better appearance. That's our figures. Now let's find the spatial mean of both datasets around Austin. Again, to make it simpler, we define an estimate rectangular boundary that we will use. After that, selecting the subset of data for the Austin region from the GrideMate dataset. Then selecting the subset of data for the Austin region from the CPC dataset. Now let's plot the two time series, but this time in degrees Fahrenheit. As you can see, the two datasets are considerably different in late February and late October. Notably, daily temperature has a lot of noise. To have a smoother plot, let's calculate the moving average of t-mean with a 50-day window. That's our new figure. Awesome. We are done with the intermediate example. You should now be able to replicate similar analysis for various data sets. There are lots of other things that can be adjusted to make the plots more interesting. You can always search for anything you'd like to do, and you will most likely find a decent answer for it on Stack Overflow.